Assalamualaikum warahmatullahi ta'ala wabarakatuh. So, kita mulakan kelas kita pada hari ini. Chapter 10, Physics STPM. Chapter 10. So, now we are talking about thermodynamics. So, firstly we have to understand the basic ideas of thermodynamics. So, thermo is refer to the heat, and the dynamics here is refer to the movement. So now we are study the movement of the heat. Okay, so first we go for this to understand this statement. So thermal energy that is transferred from one object to another object due to a difference in temperatures between the two objects are known as a heat. So this now we give the definition of the heat. So actually what is a heat? Heat is a thermal energy that is transferred from one object to another object due to a difference in temperature. So between the objects. Okay, so we look at this diagram. So we have the object A and then the object B. So both of the objects are different in the temperature. So here is the object A with the temperature, high temperature, and then object B is a low temperature. So we can see the thermal energy is moving from the high temperature object to the lower temperature object. So that's mean from the A to the B. So the thermal energy transferred. So the object that lost the thermal energy, for in this case the object A, that lost the thermal energy to the object B. So then what happened? So will decrease its temperature. So the temperature is going down for the object A. But for the object B, the low temperature, they absorb the energy from the object A. So what happened when the object with low temperature absorbs the thermal energy? So the temperature is increasing. So that is the idea what is meant by the thermodynamics. Okay, so we continue. Okay, so we continue. Okay, so here is the object, one object. So the temperature, initial temperature is theta I, and then this one also the object, but the initial temperature is theta I. I is refer to the initial, F is refer to the final. Okay, so we focus on this object first. So what happened? Object absorb heat when heated. So we heated the object. So the object absorb the heat energy. So certain amount of heat is absorbed by the object when it is heated. So when the object is heated, then what happened? So the first thing, the important thing is temperature is increases because the object absorb the heat energy. So the heat, the thermal energy. So what happened to the temperature? The temperature is increasing from theta I to the theta final. So then we go for this object. So in this case, object loses heat when the object to be cool. So that means this object is lost their heat energy. So then what happened? The temperature is decreases. So when the object cools down, so certain amount of heat escape from the objects or lost from the object, then the most important thing happen is the temperature is decreases. Okay, so that's for the idea for the heat absorbed and heat loss for the object, and then what happened? So the changes in the temperature. So we continue. Okay, so actually now we are going to understand the equation actually. So We continue. Factors determining the amount of heat energy. So the heat absorbed or losses. So the first one is a mass. Sorry. So the first one is a mass of the object. So mass of object, so the symbol is a M. So the second factor is a specific heat capacity. So the symbol is the small c, and then the unit is a joule per kilogram per Kelvin. And then the third factor is a increase of temperature. So that means the temperature will change either when the object is absorbed or loses the heat energy. So this is a three factor. So then we continue. So in that case, we can get the equation is Q is equal to the mc d theta. So Q is the heat energy. Heat energy is absorbed or lost. So this one is the Q. So of course Q, the unit is the joule, because this one is a energy. So we continue. So M is a mass of the object. So the unit is a kilogram. C is the specific heat capacity. So the symbol is C. And then the unit is a joule per Kelvin per kilogram per Kelvin. And here is a d theta is a change in the temperature, changes in the temperature. So theta F minus theta I. F is a final, and then I is the initial. So I put the modulus here because we don't want the magnitude is a negative magnitude. So that's why we have to put the modulus. Okay. So actually we have the equation. So the Q mc d theta. So don't forget this equation. Okay. So we continue. Okay. So this one is the most important thing we have to understand. So in the chapter 10, so actually is we need to understand the heat capacities. So the heat capacity. So we have the 1, 2, 3, 4. So the 4 types of heat capacities. So the first one, so we need to understand specific heat capacity. So the symbol is the small c. And then we have another heat capacity. So we don't have the word specific. We have the heat capacity. So the symbol is the big C, cap C. And then another heat capacity is the molar heat capacity. And then the symbol is the CVM. So C capacity, heat capacity. V is refer to the constant volume. M is the mole. So molar heat capacity CVM at constant volume. So CVM. P is refer to the constant volume. M is refer for the molar. Then we have another one is the molar heat capacity at constant pressure. So we write as Cp, M. M is the pressure. P is the pressure. M is refer to the mole. Okay, so we go one by one. So we go for the specific heat capacity small c. So the heat required to raise temperature of 1 kilogram of mass by 1 Kelvin. So we go for the heat capacity. So the heat required to raise temperature by 1 Kelvin. In this case, we don't have the 1 kilogram. So I repeat, so the heat required to raise temperature by 1 Kelvin. So and then we go here. So the relationship between C specific heat capacity and the heat capacity. So this one. So C is equal to the M C. And then here is the equation for the specific heat capacity. Refer to the heat capacity. Q is equal to mc d theta. And then for the heat capacity, Q equals to the MC d theta. And then we know MC is equal to the C. So we can write as the Q is equal to the C d theta. M is referred as the mass of the object. So we continue. The heat required to raise 1 mole of material by 1 Kelvin at constant volume. So this one. So I repeat for the definition or the concept molar heat capacity. So at the constant volume, the heat required to raise 1 mole of material by 1 Kelvin at constant volume. So this one is refer for the 1 kg. So but in this case, we are referring to the 1 mole of material by 1 Kelvin at constant volume. So we can write as a Q equals to the NCVM d theta. So here is the molar heat capacity at constant volume. Okay, so we go for the molar heat capacity at constant pressure. So what is mean? The heat required to raise 1 mole of material by 1 Kelvin at constant pressure. So we can write the equation for the molar heat capacity at constant pressure. So what we can see here is equation actually is the same one. Maybe because we use the CVM because we are referred to the constant volume, then this one is referred to the constant pressure. So N, don't forget, N is the number of mole. So number of mole of the object. So later we can use this one, number of mole. So in this one we use the M. M is the mass of the object. So be careful. So we understand the basic ideas of the heat capacities. So but in our chapter we are more refer to this for the molar heat capacity at constant volume and molar heat capacity at a constant pressure. Okay, for that is thank you.